So now we're going to start with the next part, which is velocity. Now obviously if we've talked about speed, it's become a necessity to talk about velocity as well, right? Because it's got some relation. You cannot say that speed and velocity, both of the terms are actually one and the same thing, but they have their similarity, but both of them are different as well in their own respective ways, right? Let's first think what velocity is, right? We should know what velocity is. We've got to know about speed. So what is your velocity? What does this word mean? What is this thing? See, velocity is defined as distance in particular direction, distance covered in particular direction upon time taken. I've written here, right, the expression for velocity. Velocity is defined as the distance covered by a moving object in a particular direction in unit time. See, let's look at the similarity. My speed was distance covered upon time, right? My distance covered in unit time. Now my velocity is distance covered, also distance covered. But now what additional thing has been added here? Yes, you're right, direction has been added here, right? So this is also distance covered. In speed we also cover some distance, in velocity we also covered some distance, but what is added is that direction of the distance that is being covered is also given. So velocity is defined as the distance covered in particular direction upon time taken, right? So that means both of these terms are actually one and the same thing, but the only additional thing is your direction. So I can call velocity as speed. I can define it as it is basically the speed but with direction, right? I can name it as such na. So I know velocity is nothing but speed with direction, and speed is speed. In speed we are not bothered about the direction, but in velocity we are bothered with direction. So that means my velocity is a vector quantity, right? Because any quantity which has magnitude and is also bothered with the direction is a vector quantity. So my velocity is a vector quantity. So now I know that velocity is a vector quantity. It is defined as the distance covered in particular direction upon time taken, right? See, what actually happened was, and how this term came to be is that, see, let's just say that I've got my two objects P and Q. I've got my two objects P and Q, and here is some point A. And I say that my two objects P and Q start moving from point A and cover equal distance in equal interval of time. I'm saying that from point A, my P object starts moving and it's going to cover some distance in some interval of time. So let me say that it covers my my P object starts moving from this point and actually stops at here, right? Now again I've got another object Q. It is also going to start moving from this point A and cover some distance and then stops right here, like this, right? So let me say that this is B, this endpoint is B, and this endpoint is C. Now what has happened is that I've got an object P, I've got another object Q, and I suppose that both of my objects P and Q, I'm saying that these two objects actually start moving from A and both of them cover equal distance in equal interval of time. Now you know what equal distance in equal interval of time means, right? If something is covering equal distance in equal interval of times, that means that particular object is moving with uniform speed. That means P and Q are moving with uniform speed. Both of them are actually covering equal distance and equal intervals. That means both of them are moving with uniform speed, which in turn means that both should have the same speed, right? Till here we have only got to know this much, right? But let me say that I want to know that after some 20 seconds what the position of both of them will be, where these two objects are going to go, or what their position is going to be after 20 seconds. I want to know that. Can you say with any guarantee what its position will be? No, you cannot say, no, because both of them have the liberty, have the freedom to move in any direction. They can move here, forward, They can even move backward or upwards or downwards. It's their own choice, they can move anywhere. So it is not possible to say with certainty in which direction they are going to move and at what point or what position they will be at 20 seconds, right? Because direction has not been mentioned. So if you want to know with certainty what the position of some object will be, of some object that is moving with some speed is going to be, you need to know the direction of motion as well, right? And in so this was the reason why this term velocity came into being, because with only speed we only got to know that how with how much speed a particular object was moving with. We didn't know in we didn't know in which direction that object was moving. So in order to know about the direction, in order to get an idea about the direction as well as the speed, a new quantity was needed. This problem was solved by this new quantity called velocity. So why was velocity introduced? Because over the time we actually wanted to know, or we actually wanted to get an idea about both speed as well as the direction of motion. So in order to satisfy this or overcome this hurdle of not knowing the direction, this new term velocity was introduced, and it was such that this term velocity actually gave us both the direction of motion as well as the speed of motion. So the direction of motion as well as the speed of motion, both of these things were given by this one single term velocity. So now you know why velocity came into being and how it came into being. See, we just only speed, only with just speed we weren't able to know the exact position of some object. So in order to know about the speed as well as to know about its exact position, after some passage of time we needed to know the direction. So we introduced one more term which was velocity. That is the reason why we call it speed with direction as well. So we are getting both of the things, speed as well as the direction. So let's define this term velocity, which clearly actually tells us the definition part. See, velocity, now we can define it as the distance covered by a moving object in a particular direction. Now let me remind you, or let me tell you what distance in covered in particular direction means. If you have watched the previous 3 videos, you probably know by now there is a one single word that can be used in place of this whole statement: distance covered in particular direction. Is there any word or any term given to this particular statement? What do we call distance covered in particular direction as? Displacement, right? We call it as displacement. We know that what displacement is. It is distance covered in some particular direction, right? We know it as displacement. So this term can also be written as displacement upon time. So that means your velocity is speed with direction. Also we can say that velocity is rate of change of displacement. With this we come to know about what velocity is, how it came into being, what type of quantity it is, whether it is scalar or whether it is vector. And we also got to know that with speed, with velocity, what are the two things that we come to know of. We come to know about the speed of motion and also about the direction of motion. Now what are its unit? Let's talk about its unit. Distance covered in particular direction upon time taken. Again it's same unit, meter per second, right? Because distance covered unit is going to be meter, and time we take it in seconds, so meter per second. Now so one thing that is similar in both of them, speed and velocity, is that the units are same. The unit of speed and velocity are same. Unit of speed is also meter per second. Unit of velocity is also meter per second. But are they both one and the same quantity? No, they are not. Right? You do know they are not. the same quantity. Why? Because speed is a scalar quantity, as it doesn't mention direction, while velocity is a vector quantity. It has both magnitude as well as direction. So now, just like speed, there are also two types of velocity as well. And what are the two types of velocity? Again, the same types of velocity, uniform and non-uniform, right? So we've got uniform as well as non-uniform. Let's talk about uniform velocity. First of all, let's talk about uniform velocity. Actually, we can have the understanding of both these types of velocity with one single example, and let's try to actually understand them using one single example as well, right? So uniform and non-uniform velocity, we will try to understand them using a single example. Let me say that there are two athletes. I say that there are two athletes. A is one athlete and B is another athlete, right? I've got two athletes, A and B. Both of them are running, but my A athlete is running along a straight line, or he is running on a straight line along a straight path, while B is running on a circular track, and both of them are moving with uniform speed of, let's say, 5 meter per second. So both of them are moving with uniform speed, that is, their speed isn't going to change. It is going to remain as 5 meter per second throughout their whole journey. They are moving with uniform speed, right? So that is, they are covering equal distance in equal intervals of time. Both of them, their speed is same, 5 meter per second. A is also moving with 5 meter per second of speed. B is also moving with 5 meter per second of speed, but A is moving along a straight line path, B is moving or running on a circular track. Okay, so if I ask you what kind of motion, what kind of velocity are both of them moving, you will say that they are moving with uniform velocity, right? Why you will say that? You will say that because they are moving with the same speed. If they are moving with the same speed, then they are also moving with the same velocity. Why? Because velocity is basically also similar to the speed, distance covered in direction upon time taken. So distance that is being covered in unit time is same for both of them. So both of them should be moving with uniform velocity, right? For layman, it is actually right. For layman who doesn't know the concept of velocity, who haven't actually studied velocity in deep, is actually right. According to his point of view, it is right that both of them are moving with uniform velocity. But a person or a physicist or someone who has studied the concept of velocity, he should know that the only athlete that is running with uniform velocity, or that is moving with uniform velocity, is actually only athlete A, while athlete B is moving with non-uniform velocity, and this one is moving with uniform velocity. Now you may ask me a question, how is it so? What has happened? What actually happened that one moved with uniform and the other just changed or transformed his motion velocity into non-uniform? What actually happened? Did some kind of magic happen? There was no magic that happened. What happened was that my athlete A is actually running along a straight line. That means his speed definitely is going to remain same. And what about his direction? Is it going to remain same? Yes. So that means his speed and direction both are same. There is no change in athlete A's speed and direction. So if there is no change in speed and direction of the motion, I can say that yes, in that case it particularly satisfies the definition of uniform velocity, and I can say that my athlete A is moving with uniform velocity. But when you look at the motion of athlete B, even though speed is not going to change, but see, he is moving in this direction initially, but after some time he's going to change his direction. So what has happened is that even though there was no change in the speed, there was a change in direction. and only a person who knows that velocity depends upon both speed and direction is able to differentiate between the two cases and actually tell you which athlete is actually moving with uniform velocity and which isn't. So from this we conclude that an object is said to be moving with uniform velocity if the speed or the direction of that particular object doesn't changes. That means if some object covers equal distance in equal intervals of time and also in a specified direction, then that particular object is said to be moving with uniform velocity. Let me again repeat it. If a person or an object is covering equal distance in equal intervals of time in a specified direction, in only one particular direction, then we can say that that object is moving with uniform velocity. However, if an object either covers, there are two cases in non-uniform velocity. Either your object can actually cover unequal distance in equal intervals of time, or he can change the direction, or it can change the direction. In this case, the case that we considered was that the speed wasn't changing, but there was a change in direction. If you got a change in direction, it will be quite easy of you to identify. You can easily say that by looking at the speed, if your speed changes, you can easily say that this is the case of non-uniform velocity. But more tricky thing is is in understanding the concept of direction. It is only if you understand the concept of direction you can actually have the complete knowledge of velocity. So that is why the example that I took was the one in which speed was remaining same but direction was changing. So now you know, if your speed isn't changing but my direction is changing, then I can also call that particular motion as the case of non-uniform velocity. Okay, so that means I can now understand the definition of non-uniform velocity. If either my object covers unequal distance in equal intervals of time, or if my object changes its direction, then that particular object is said to be moving with non-uniform velocity. So can we write it here? Uniform velocity, non-uniform velocity. Uniform velocity, speed and direction remains same. Non-uniform velocity, speed and either speed or direction changes. So this concludes my topic velocity. I hope you understand. If you have any doubt, go through your notes. If you still do not understand, then once again try to listen to the video. You will probably get even the smallest points which you weren't able to understand in the first go.